Huge news, Toyota new ammonia engine will destroy EVs. Have you heard about Toyota's groundbreaking new ammonia engine that could potentially revolutionize the future of transportation? Imagine a world where hydrogen-powered engines and electric vehicles are no longer the only contenders. Could this new technology actually outshine EVs and change the way we think about energy in cars forever? With such bold claims coming from one of the world's leading automakers, you won't want to miss what this could mean for the future of driving. Could this be the end of the electric car era as we know it? Over the course of its history, Toyota has garnered a lot of attention when it comes to its innovative fueling ambitions and ideas for alternate forms of energy. I was wondering if anyone remembers the hydrogen-powered 5.0-liter V8 RCF engine that Toyota commissioned a couple of years ago. Okay, that is some fairly forward-thinking stuff, for sure. Toyota is not only experimenting with hybrid motors and hydrogen engines, yawn, but it is also exploring other areas of technology. As more and more individuals come to the realization that the batteries that power their electric vehicles are significantly more harmful to both the environment and human health than the manufacturers of automobiles would have you believe, alternative fuels have swiftly emerged as the buzzword of the moment. Please take into consideration all of the excitement that has surrounded the engine that Toyota developed in conjunction with the Chinese automaker GAC Motor. It would appear that this device is intended to consume ammonia and generate power without emitting any carbon dioxide through the exhaust pipe. The issue of using ammonia as a viable fuel source for internal combustion engines is far more exciting to us here at Engine Labs. Despite the fact that there is a lot of chatter about Toyota cannibalizing its electric vehicle sales with a project of this particular caliber. After all, when ammonia is transformed into a liquid state, does it not represent a significant threat to the environment and a significant environmental impact? A single molecule of nitrogen and 3 molecules of hydrogen are the components that make up ammonia. Despite the fact that it is composed of 1 part nitrogen atom and 3 parts hydrogen atom, good old Uncle Ammonia has maintained his position in the scientific table as the NH3 slot for a very long time. When viewed from a molecular perspective, he does not appear to be all that awful of a guy despite appearances. In light of the fact that there are no carbon atoms in the atmosphere, the amounts of carbon dioxide that are produced by burning ammonia appear to be as low as they can possibly be. When you start to take into account the amount of energy and equipment that is necessary to make the substance viable as a source of fuel for a combustion engine, you become confronted with a large number of new variables to take into consideration. Ammonia, like Toyota Denso's microalgae biofuel project from a few years ago, which we haven't heard much about since 2015, takes an absurd amount of electricity to be transformed into a viable source of fuel. This is similar to the situation that occurred in 2015. The hydrogen atoms that are included within the ammonia might, without a doubt, be converted into a fuel cell source in order to generate power. On the other hand, this would require Toyota and GAC to force a new teat into the mouth of an electric vehicle toddler that is rapidly developing and that they have just sworn to wean. We are left with the most likely and easily attainable option, which is to provide old Uncle Ammonia with a potent cocktail mix and hope that he is capable of standing on his own when everything is said and done. In order to use ammonia as a fuel for motor vehicles, the existing infrastructures would need to undergo considerable transformations, not only in terms of ammonia production, but also in terms of fuel storage and transportation. Would you like a hunch-punch spike with ammonia? Despite the fact that this fueling innovation may sound like breaking news, the Ammonia Energy Association claims that Toyota has been experimenting with alternate fueling solutions that use ammonia for quite some time. As of the last time we checked, the corrosive chemical compound was still being utilized in conjunction with an organic slurry that was extracted directly from the farmlands in the surrounding area in order to generate electricity for Toyota City, which is located just outside of Nagoya. The answer is yes. Toyota did in fact construct a city in Japan and give it its own name. The concept appeals to us. Is it just me, or do you believe that the name Engine Labs Avenue has a pleasant tune? GAC claims that the prototype engine that it created in collaboration with Toyota is capable of being driven by liquid nitrogen, NH3. This is due to the fact that this chemical compound may be blended with diesel, gasoline, or even hydrogen to produce an ammonia hunch punch, an innovation that, up to this point, has only been utilized for the transportation of goods, agricultural machinery, and ships. It is also surprising to see a claim that a 2.0-liter four-cylinder engine can create 161 horsepower on this stuff, while also reducing carbon emissions by 90% compared to the emissions produced by pump gas. In the event that it is manufactured, this vehicle has the potential to become the very first passenger car fueled by ammonia to ever be driven on a public highway. We were able to overcome the challenge of ammonia being difficult to burn quickly and find a way to put the fuel to use in the passenger car business. It would be prudent to anticipate its value to society as well as for commercial applications. In addition, GAC notes that in order to make their ammonia engine clean enough to operate, it was necessary to reduce the amount of nitrogen emissions. This was accomplished in part by increasing the pressure at which the combustion process occurs. And despite the fact that the car maker acknowledges that the fuel with a slow combustion rate has approximately half of the energy density of gasoline on a per-gallon basis, the combustion of liquid ammonia is the one that deserves the most attention. In the event that it is burned in the appropriate manner, liquid ammonia has the potential to be fully devoid of carbon, hydrocarbon, carbon dioxide, and particle emissions, the negative qualities of ammonia. This new ammonia engine collaboration project between Toyota and GAC does have some fascinating merits that warrant a quick mention. Nonetheless, we have just as many questions and reservations about it as we have about other things. In the first place, there is the fact that ammonia typically has more warning labels that are associated with its dangerous properties than a jar of electric nacho cheese at a truck stop. Therefore, anything that pertains to the maintenance or improvement of the fuel system in an automobile would be incredibly difficult to arrange in a manner that is both safe and affordable. Furthermore, if these engines do not maintain enough levels of high compression or boost, they will result in the emission of a large quantity of nitrogen into the environment. This is a problem that cannot be ignored. In light of this, an ammonia motor that is not properly tuned or that is not functioning well has the potential to cause significant harm, since it would result in the emission of even more ammonia and ozone into the environment. Birth deformities, respiratory problems in children and the elderly, and acid rain are all examples of this substance has the potential to cause anything you can think of if it is burned in an improper manner as well. Don't miss out on the latest updates. Hit that subscribe button and turn on notifications so you're the first to know about groundbreaking innovations like Toyota's new ammonia engine and much more.